Welcome students. In today's video, we're going to take a look at inequalities and how to write them and then graph the possible solutions to those inequality statements. Before we get started though, what do parallel lines and vegetarians have in common? They never meet. Get it? They never meet. No. Okay. All right. Anyway, we talk about inequalities. Those are comparisons between two values that show if one is less than, greater than, or not equal to another value. When we see inequalities, we have greater than or equal to, and less than or equal to. And we're going to look at some of the vocabulary that's associated with each of those, as well as an example of what the graph might look like. So we talk about greater than, we see words like more than, over, longer than, right? Where we're comparing and we're saying that something is bigger in value than that number. And when we think about something being bigger in value than that number, the number itself is not included. So when I look at the example x is greater than 2, 2 is not actually greater than 2. So when I graph this, I put the circle at 2, and then I extend the arrow to the right, showing that it's all the values that are larger than 2 are possible solutions to this inequality. However, 2 is not a solution to this inequality. So the circle remains open. You don't fill it in. Now when I look at less than, I see words like fewer than, under, or lower than, and our arrow now is pointing to the left to show that it's values that are smaller than that. And again, my circle remains open because 2 is not less than 2. Okay, when I look at greater than or equal to, I see words like at least, or minimum, or more. The or more is a little bit tricky because we see more than for greater than, but if it's or more, then we see it as greater than or equal to. Because if I say, I have $4 or more dollars, what I'm saying is I have $4 or more than that. So 4 is included, therefore it's or equal to. And because my value is included with those or equal to statements, my circle is filled in. Because now when I look at the example x is greater than or equal to 2, 2 is a part of my solution set. So therefore that circle is filled in and the arrow is going to the right. With less than or equal to, we see words like at most, or maximum, or less. So if you have a maximum of 2, that means you could have 2 or you could have less than that, right? You could have 1 or 1/2 or even negative values. So my circle goes at 2, but because 2 is a solution to that, 2 is less than or equal to 2, my circle is filled in. All right, now let's take a look at a couple of examples that we can use to illustrate how to do this. So we have an example situation here. It says, Grandma lost the remote control at least 3 times while I was visiting yesterday. Oh, has anyone seen the remote control? When we're talking about at least, that's our vocabulary word there. We see that word at least. I'm sorry, that phrase at least. So if Grandma lost the remote control at least 3 times while I was visiting yesterday, that means she could have lost it 3 times, right? But she also could have lost it more than that. So that would be greater than or equal to 3. So when I'm trying to graph that, remember, when we say x is greater than or equal to 3, there are an infinite amount of values that are 3 or more. So we can represent that using a graph on a number line. My circle will go at 3, because that's where my solutions start. And because it's greater than or equal to, I'm going to fill in my circle, because I'm showing that it could be 3, but it could also be the values that are larger than 3. So my arrow is going to extend off to the right. Okay, let's take a look at another example here. Grandma has more than 3 plastic margarine containers in her refrigerator, none of which contain margarine. Grandma, I just need some margarine. Why do none of these containers have margarine? They all have soup in them. Anyway, that's a personal thing, I guess. But when we look at this, more than 3 plastic margarine containers, right? So because it's more than 3, 3 is not more than 3, right? It's got to be a number that's larger than 3. So this is going to be x is greater than 3. And because 3 is not more than 3, my circle is going to remain open here at 3. 3 is not a solution there. I can't substitute 3 for x and make that a true statement. 3 is not greater than 3. But all the values that are larger than 3 do count. So I just put my arrow off to the right there. And now it's interesting to note, 3 is like your limit there, right? 3 is not your answer, but any number that's bigger than 3 works, no matter how small. Could be 3.1, and that still works as a solution there. All right, let's take a look at one last one. Grandma has at most 3 cookies left in the box that has been sitting in the back of her pantry for 2 years. Those are some stale, gross cookies, but you won't throw them out. They're still good. Okay, so because it's at most, that means x has to be less than or equal to 3. 3 is the highest it could be. It is at most 3, but it could be less than 3, right? So we're going to put a circle at 3 to show that that's the possible solution there. And now I see that 3 is a part of my solution because it's less than or equal to. So I'm going to go ahead and fill that circle in. And then these possible solutions, again, it's less than or equal to. So my arrow here is going to extend off to the left to show that those values that are smaller than 3 are the ones that are possible solutions. All right, so in this video we talked about just how to write an inequality, what the inequality statements mean, some of the vocabulary, words that are associated, and then a quick tutorial on how to create our graphs to represent those. Thank you very much for watching. I appreciate your focus. Make sure you're hitting the subscribe button so that you get notifications whenever we post new videos, and I hope you have a great day.